All right, here we go again. Similarity. Today we're going to talk about AA similarity. And if you remember what we talked about with congruence, uh, maybe you'll guess that this stands for angle-angle. So we'll talk about ways to prove triangles similar using angle-angle similarity. So to start off, let's just review what we know about similar triangles. I would like you to just take some time and write down everything you know about similar triangles. What's a definition? What's your definition? What are some properties that similar triangles have? Give me an example or two and show me one that doesn't work. So take some time to write that. I'll provide some of my own examples after you pause the video. Start again when you're ready to see what I wrote down. Okay, so to see what I wrote down is that triangles are similar if they have the same shape. They can be different sizes though. Properties mean they have congruent angles and proportional sides. Here's an example of two triangles that have congruent angles and sides are proportional in a 1:2 ratio. These are an example of not similar, not triangles that are non-similar. You can see that their angles are not congruent and the sides are not proportional either. You can tell just by looking at that. We're going to take a look at GeoGebra and explore the angle-angle similarity model. Okay, so I have two triangles, one with side length 7, one with side length 5. The angles for both of those are going to be 35 and 59. So if I draw those lines in here with the angle of 35, and another one at 59, notice they meet at C and meet at F. Now, they look like they are fairly similar. First of all, what do you know about triangles if two angles are the same? What's true about their third angles? We referred to the third angles theorem earlier this year. Let's make it a little bit easier. If this is 90 and this is 35, 90 plus 35 is 125. Means I have 55 left for this angle. 90 plus 35, 125. 55 left for this one. So if I have two angles the same, I know the third one's going to be the same. Okay, let's put in the side lengths. Side lengths, so first of all, we see that the angles are congruent. Side lengths should be proportional. So if I match up AB to DE, it's a ratio of 0.71. And AC to DF is 0.71, and CB to FE is 0.71. I need to zoom in a little bit so you can see that better. But you say, well, maybe that just works for that specific triangle. Let's change the size. All right, so now let me do that. Let me shrink it back down again. Okay, so let's move this around. I'm just going to have to start it over and try again. Hold up. All right, I think I got it now. Let's see, I can change these. Take a look at these ratios. Do the ratios change at all when I change the size of the triangle? If I know two angles are set to be the same, the other side lengths, another angle changes. So notice the side ratios always stay the same. Even if I move this thing around, it always stays the same. So that shows that no matter what we have, if we know two angles are the same in a triangle, we can prove that the triangles are similar. So that sounds like it's pretty important. You're going to want to record that in your notes. So here we go, the AA similarity postulate. If two angles of one triangle are congruent to two angles of the other, the two triangles are similar. So triangle JKL similar to triangle XYZ. Making sure I match up corresponding angles. So can you tell if these triangles are similar? If so, write a similarity statement. Well, you tell me. I know you can't tell me since I can't hear you right now, but write it down on your page. Are these triangles similar? So how do we know? I'm going to say triangle CDE is similar to triangle KGH. Well, I know D and G are the same. They're both right angles. This is 26. Well, what's angle E? Well, I know this is 90, so I only have 90 degrees left in the triangle. 90 minus 26 happens to be 64. And that's the same as angle H. So E and H are the same. Angle C is 26. What's angle K? Well, this is 90, so that leaves me with 90. So 90 minus 64 gives me 26. All the angles are congruent, so this triangle must be congruent by angle-angle similarity. We don't even need to prove that the sides are proportional because we saw in our GeoGebra exploration, I can't spell, similarity. In our GeoGebra exploration, we saw that if we have two angles congruent, triangles must be congruent, or similar, rather. All right. Determine if these triangles are similar. Pause the video, start it again when you're ready. So I can prove both these triangles are similar by AA Similarity. First example, ABE is congruent to ACD because that's given to me. And EAB is similar to, or congruent to DAC because it's the same angle, the reflexive property. So I've proven that at least two of the angles are similar or congruent, so the triangles have to be similar. Next example, I can prove that also by AA Similarity. VSR and VUT are alternate interior angles because line RS and TU are parallel. The same goes true for VRS, maybe use a different color, VRS and VTU, because those are alternate interior angles as well. So those are congruent. Remember, when lines are parallel, alternate interior angles are congruent. And then I can also say, if I want to, that SVR is congruent to UVT because vertical angles are congruent. So I have proven all three if I wanted to. I don't need all three, but two is all I need, so just pick any two you want, and that proves that these triangles have to be similar because their angles are congruent. So now how do we use this information? Let's apply it. So let's say that you're standing outside on a nice sunny day, and you are standing by the flagpole outside school. The flagpole casts a shadow that's 50 feet long. And you're wondering to yourself, how tall is that flagpole? Well, you know how tall you are, and you know that you are 5'4", and your shadow you measure is 40 inches. So you ask yourself the question, how tall is the flagpole? So, taking that information, how do we know that we can compare these two? Well, I can draw an imaginary line from the flagpole to the shadow, and from your head to the shadow, and we see that we should have similar triangles because we're both standing at a 90-degree angle, and the sun is in the same location and it's hitting at the same angle. So I know that these angles will be the same, or these angles down here will be the same, since the sun is hitting us at the same spot, since we're standing pretty close to the same location. So now we know triangles are similar, and if triangles are similar, we know sides are proportional. So we just need to set up a proportion. So I know that this side, my height, I'll just call that me height, to flag height will be proportional to me shadow over flag shadow. It's just a matter of filling in the blanks. So me height is 5'4". Notice we have different measurements. Feet and inches, just inches and feet. So let's convert everything. Looks like our answer wants to be in feet. So let's convert everything to feet. So 5 feet 4 inches is 5 1/3. And the height of the flagpole is, we don't know. The shadow for me is 40 inches, which 36 inches is 3 feet. So at least 4 left over. So 4 out of 12 is 1/3, so 3 1/3 to 50. If you don't like to use fractions, with the feet. Maybe you prefer to change it all to inches and then convert to feet later. So let's do that as well. Let's set up a proportion, and you can decide which one you want to use to solve it. So 5 feet 4, 5 times 12 is 60, so I've got 64 inches. And my shadow is 40 inches, and 50 feet is quite a few inches. So 10 times 12 is 120. Times 5 would be 600 inches. Now it's just a matter of solving either proportion. Go ahead and do that. Okay, so you can check my work for both proportions, and keep in mind that you might set up your proportion a different way. You might set up me height over me shadow to flag height over flag shadow. It doesn't matter, just as long as we're matching up corresponding sides. So I multiplied using my cross products property. 50 times 5 1/3 is 800 thirds. X times 3 1/3 is 10 thirds x. Multiply both sides by 3. I get 800 equals 10x divided by 10, x equals 80. Since we're measuring in feet, that's 80 feet. Check to see if my inches is correct. 600 times 64 is 38,400 equals 40x divided by 4,960, that's inches. Divided by 12, I get 80 feet. So they both match up, so hopefully I'm right. 80 feet tall is the flagpole. If you want to find out the height of our flagpole, well, you could do the same thing on a sunny day. So we've taken a look at how to prove triangles similar by using angle similarity. And once we know triangles are similar, as always, we could set up a proportion to find missing corresponding parts.